Heißt so ein bisschen Reise nach Jerusalem, ne? Also wenn die Musik alle ist, müssen sie sitzen. Welcome, ladies and gentlemen. Welcome to Covestro at the K Fair. Quick question before we get started. Who of you actually has downloaded this app onto his mobile device already? 1, 2, 3, 5. That's not enough. So I'll give you a couple of clues and hints later on after the keynote as to how easy it is and how worth it is to actually do exactly that. But first, of course, we're going to get some information flow going. So welcome to Covestro and the Car Messe. Covestro wurde ja 2015 gegründet, and it is going strong ever since, as you know. It's a world-leading polymers company, ein Unternehmen, das Produkte herstellt und ermöglicht, die wir eigentlich überall in unserem Alltag finden. Und bei allen Entwicklungen will Covestro immer nur eines: to push boundaries of what is possible, to make the world a brighter place. Daher mal eine kurze Frage an Sie, a quick question to you. What would make the world a brighter place from your point of view, sir?
Colors.
Colors! We've never had that before. What made you think this? The millions of square meters of Makrolon we have, I guess. What do you say, madam? What makes your world a brighter place? Oder auf Deutsch? Nothing so far. Nothing. Go for world peace, that's always safe. Okay. Well, you see, it's always important to communicate. Übrigens, Sie können wirklich auch gleich Fragen stellen. Of course, you can ask questions too. Later on, after the keynote, we have a Q&A session, because innovation is always about co-creation and communication. Okay? So, also Covestro möchte erreichen, dass die Welt a brighter place wird. Und zwar in segments as automotive, construction, electrical and electronics industries, as well as wood and furniture, sports and leisure. Doch wie sieht sowas aus? What does this look like when innovation knows no boundaries? It's all present. It's in the office. It's right underneath your rear, actually, like this. It's a collaboration with colleagues, customers, and suppliers that this happens. And it's along the entire value-added chain. Und wie das konkret aussieht, das werden wir jetzt gemeinsam erfahren. Our upcoming keynoter works for Dell, who's been utilizing carbon fiber for many years. And he's being pushed by the idea to do things that have never been done before in this specific industry and spread it across the entire Dell portfolio of products. Now, Dell has been utilizing carbon fiber for many years, he says, but the challenge is how to bring carbon fiber part production from batch process to high volume capable processes. As he says, this goal is nearly impossible using thermoset-based composite materials. It can only be realized by taking advantage of thermoplastics. And that about sums up everything I know about the topic. So it's great to have him here as well to explain the rest. Please welcome from Dell Technologies, Nick Abbatiello.
Thank you. Well, thank you very much. So kind of gave you a great introduction of what we'll talk about a little bit today. So on the first slide that I'm going to give you a little brief history of what we do, how long we've been using carbon fiber here in Dell. So about 5 years ago, we actually shipped the first carbon fiber part on an XPS product line. It's all was thermoset based. We've used it, we learned what not to do and learned what we should do the hard way. We then translated that to our Latitude product line, which is for an A cover, top cover, sorry, I'm using our vernacular. We've been shipping that for about 3 years now. And again, mostly that has been done with thermoset materials, primarily because the thermoplastic materials just have not been ready. Right? We started looking at thermoplastics perhaps 5 years ago when we started initially investigating how do we do carbon fiber. At that point, there wasn't the suppliers ready, the material wasn't ready, the quality of the material just wasn't ready, the performance of the material wasn't there. But over the last 5 years, there definitely has been that evolution of the thermoplastic industry to create the materials that we need and the quality that we need and the supply that we need to be able to spread that a little bit further. following on from the Latitude products, we went and then did mobile precision products. Again, with a top cover application. We've been shipping that for approximately 2 years now. And even when I think about composites and I think about carbon fiber, we've been doing we started doing injection molding of carbon fiber as well, maybe about 2.5, 3 years ago, again into our Latitude product line. So for us, it's really about how do we take advantage of composite, whether it's chopped small particles or continuous carbon fiber or somewhere in between or some combination of those different technologies. That's kind of the beauty of thermoplastics. You can take the different things and you can merge them together quite easily. They stick together, they work together. There's easy ways to bond them together. That's what the uniqueness, and that's the advantage again of doing thermoplastics. So here's just a couple of pictures of products that we currently ship today. The one is an XPS. It's on our consumer brand. It's a premium flagship material in our consumer brand. We have a 13 and 15-inch version. And on the palm rest of every part, it's carbon fiber, along with injection molded plastic there to kind of give you the keyboard lattice. But we utilize that material for the aesthetic, right? And also because it gives us a good strength to weight ratio. As I mentioned, we started shipping those materials as well in our Latitude product line in the top cover, A cover there. And we've shipped that for approximately 3 years, and I would say, overall, I don't have the exact number, but we've shipped millions and millions of composite parts between our XPS products and our Latitude products and our mobile precision product line. And again, predominantly has been thermoset-based materials because that's what's been available. We are slowly making the transition into using thermoplastics, again, just because there's so many advantages of thermoplastics. The other thing is that the performance gap between thermosets and thermoplastics that's once existed has kind of disappeared. Especially in the woven materials, the stiffness differences, and for us it's about flexural stiffness. This flexural stiffness of the materials is almost equalized. So for us it doesn't matter from a performance point of view, and then it really becomes what other advantages can you bring with the thermoplastics. So why utilize carbon fiber in the electronics industry? Well, I mean, it's quite obvious. It's got the highest stiffness to weight ratio of any material, right? So it brings some advantages. All of you want to carry something that's lighter, something that's thinner, something that looks good, right? You don't want to carry, you don't want to carry a 5-pound notebook when you travel all the time. So there's an advantage to that, right? There's an advantage to having something that's thinner. There's a competitive advantage. It also provides us the opportunity to have a leadership position in evolving technology, right? We want to be first, right? There's an advantage to being first and setting what the future looks like instead of following. That's a big one for us. It provides a real premium material and premium aesthetic, right? As you saw in those pictures, it gives you that premium value, that feel of the material. And you'll see it in the automotive industry as well, in high-end cars, showing the carbon fiber, showing the composite, and leveraging the fact of how the material looks to create that value. And actually, for us, it's great that the automotive does these things too, because we follow. Right? We can follow along the things that the automotive industry does and leverage those things as well. As I mentioned, it's versatile. We can chop it. We can use continuous. We can use non-wovens. We can use roving fibers. You can use combinations of those things. And what I also mean by versatile that I didn't put up here is you can customize it. When you're working with aluminum or magnesium or any other homogeneous material, you have what you have. You really can't take aluminum and modify it to make it a little bit lighter if you need to. You're kind of stuck with the properties of the material. That has some good things because you know what you're getting all the time, but it also has some bad side is that you can't really customize it. For us, if we want to, we usually play off on cost and weight and stiffness of materials. If we want to say, hey, this one is really cost sensitive, but we still would like to use the carbon fiber, But weight isn't so bad. Weight isn't such a problem for this particular product because we can make up the weight difference somewhere else. Then we can slide the construction, we can change the construction of the laminate to use materials that are more heavy but less expensive in the core. On the other side, if we want to make something that's really, really thin, we can use more expensive materials in the carbon fiber. We can use higher modulus fibers. We can do different things with the core layers. And we can create a material that matches that set of requirements. You know, again, with aluminum or magnesium or any other homogeneous material, you really can't play that game of trade-offs with the material properties that exist. It can be customized is a little bit what I was talking about. We can tweak and play and maneuver and manipulate the material. And in fact, you know, we've learned a lot over the last years of testing hundreds, if not thousands, of different constructions of laminates about what is exactly important to us and how those properties and what that means from a material formulation point of view. And that, I think, is what will drive us to continue to have the leadership position in composites. We know the material. We know what the formulations, what works best in our applications. We know how to communicate now with the suppliers. We know how to give specifications now to suppliers. And that's a big thing. When you can speak the same language and you can explain what you're needing and giving good specs to companies like Covestro, that allows them to develop and innovate their product line as well. So what is the challenge? Why aren't more people, why isn't carbon fiber proliferated further into the market? Well, you don't really have high volume manufacturing capability today. If you look at the thermoset process, and it was made to do bikes, right? It's made to do airplanes. It's made for these processes where you're not building millions upon millions upon millions of parts. And it does quite well for those things. But when you try to take a thermoset material, thermoset process, and move it to I'd say, high volume product like a computing equipment or electronics equipment, it just doesn't necessarily translate over. When you're talking about very long cycle times and you need a lot of equipment, as you can imagine. And then you're talking about rooms and rooms and rooms of equipment to make millions of parts, which is not necessarily the right thing to do, right? It doesn't seem to make sense. And what I've learned is when I go tour these factories and look at our supply base, when they are using thermoplastics, they're still treating them like a thermoset. So even though it's got a different resin and it's a different material, it still follows the same exact process as if they were processing an epoxy or another material. So when you step back and look at it, you go, well, why aren't you taking advantage of it? Why aren't you taking advantage, or how do you take advantage of the fact that you have a material that is not cross-linked, it's not thermosetting, it's got flexibility in what you can do from a process perspective and point of view. And that's where I think you can really innovate. Efficiency is the key to anything. And I think we share a lot of the same challenges that the automotive industry that they want. I mean, they want lighter materials to have better fuel economy. We want lighter materials so that our customers like using our products better than our competitors, right? Or when you travel a lot, that you don't have to carry that 5-pound notebook through the airport all the time. But efficiency is probably the biggest issue. And what I mean by efficiency, I'm talking about yield rates, right? Of course, yield rate means cost. And cost is important to everybody, right? And that's the biggest barrier is right now cost. Versus competitive products or competitive materials, there's a fairly significant cost gap still between the products. And when you step back and look at it, it's driven by the inefficiency in the process. It's not that the carbon fiber plate costs too much, and that's the reason. It's more of throughout the process, you're throwing away so many parts that at the end of the day, you have a fair amount of your cost is just scrap. And I'm sure that's no different than airplanes being built and cars being built today that are using carbon fiber. If they truly look at what their yield rates are and the process that they're using, they're scrapping quite a lot of material. And then not only is it a problem from a cost point of view, but environmental point of view. What do you do with it? What am I doing with all those parts that I'm scrapping through this process? And that's something we step back and look at from an environmental point of view. We don't want to be doing that. We don't want to be throwing away all those parts, and unless we absolutely have to. But again, the advantage of thermoplastics is improving that efficiency of the process. Right? There's been years and years since polycarbonate has been developed, with 60 years, 63 years, 62. So polycarbonate's been around a long time. Composites have been around a short period of time. But how do you take advantage of everything else that we've learned over those 60 years of manufacturing and process innovation and bring them into the composite industry? Supply chain. And what I mean here is, having suppliers that can actually make product and are familiar and comfortable with it, but also looking at common processes. So think about it from a point of view, if I'm using 4 different types of materials, and I'll say I'm using 4 different types of thermosets, or some thermosets and some thermoplastics, when I have an issue or a manufacturing problem, or manufacturing shutdown or something like that, how do I go in and troubleshoot the process? I have 4 different processes. So now my team has to be an expert in 4 different things, 4 different materials. You might have the same problem at the end. Maybe it's some visual defect or something, but the root cause is going to be totally different. Someone changed something in this epoxy, and now we're getting this other defect. But you're not going to be able to leverage those learnings when you go to a different supplier. The different suppliers using a different material, a different formulation, different. So how do you go back and say, well, we're seeing that again, but now we have to go through the whole process again to figure out exactly what's driving that and what the root cause is. When you look at things like, again, thermoplastics and bringing this in, the commonality of the material being that it's all thermoplastic. And in our industry, we need flame retardancy, so that tends to lead towards polycarbonate-based laminates. So there's a lot of commonality that's going to happen. And then from a common process, if you can develop a process that's efficient in converting these into parts, that means how do you can just share that process across multiple suppliers. It doesn't become unique to their particular brand of thermoset or their epoxy material. It actually, you can make it common or semi-common at least. Yes, everybody has a little bit of their own individual process and their own process IP, but it just becomes much simpler to scale. Imagine doing millions and millions of parts with 4 different types of materials. It becomes a nightmare. And the last thing I always mention is cost. And again, I mentioned before, cost isn't so much the cost of the plate. It's not so much how much the carbon fiber material costs. In the end of the day, we learned years ago that we're good at beating down our suppliers sometimes. We're good at negotiating costs sometimes. But the fixed cost is actually the fiber. Right? In the end of the day, electronics from the fiber suppliers of the world, we're just a small little, blip, of usage of material compared to aerospace industry, for example. So long ago, we realized that trying to go negotiate fiber costs is not the best way to get costs down, right? And it's not the best thing to go push your suppliers because they have nowhere to go either, right? There's this fixed constraint of the fiber. So from a cost, it means how do you focus on process? How do you use the process to take the cost out? I mean, that's just waste, right? If you're putting that much into the trash can every day and when you're making parts, that's just waste. So how do you recapture the waste? And how do you create an environment that's a win for everybody? A win for us, we get the lightweight, we get the premium aesthetic, the win for the material supplier, and everybody has to make money in the end of the day to continue to innovate. Right? If there's not profit in every piece of the equation, then nobody wants to do it anymore. And what's the point of driving innovation if everybody's not there to make some money, right? And in our case, saving some money and making some money is always a good thing. Okay, that's my presentation. I don't know if there's any questions. I'll be glad to take any questions.
I guess, first of all, there's a round of applause for you.
Thank you.
Excellent. Thank you very much. That was, for me, it was absolutely mesmerizing because it was a completely new field. Of course, I use PCs. And that brings me to, if there's no question to start us off from the audience, I do have a couple of questions regarding the stuff that you presented. Is there anything you want to know? You want to ask him? You want to clarify? you want to teach, anything you do. We have microphones, I warn you. Your voice will be heard. Yes?
I'm interested about the material itself. You're talking about waste, about pricing, but what is so interesting about the material by itself? What are the possibilities?
Well, I think weight is probably the most attractive purely from an engineering point of view. It's weight. I work with designers every day. My function reports into the design group. They would tell you that the most important thing is the aesthetic, right? They love the premium aesthetic of the 3K weave. And actually, from a marketing point of view, they like the 3K weave aesthetic as well. It becomes something for them to talk about with their customers. And from a designer's point of view, it allows them to, again, create that premium look and feel. From a purely engineering point of view, it becomes weight. In our market, believe it or not, 30 or 40 grams is a huge, huge deal. 0.2 millimeter and 30 grams is a big thing. So anywhere, and you think about a construction of a notebook, we're running out of places to take out weight. Right? Where else can you remove weight? And also, you trade off weight. I can reduce weight in the cover. I can add more battery. You know what I mean? So then that's a better experience for you, is you can have 8 hours of battery life now versus maybe 6 hours of battery life. So we play those kind of with trade-offs with the material.
Okay, did it answer you? Does it? I'll try again. Does it? Oh, my microphone's not working anymore. Is it? Yeah, it is working again, and we've got a second question. Yeah. What a way. You need a microphone as well.
Nick, would you see this spreading also across like more common parts rather than only the high-end models that you're using?
Yeah, that's certainly our desire, is to spread that across a wider portfolio of products. As I mentioned, right now it's kind of limited to our upper tier, upper echelon of products, just because of the cost. And the cost differential with competitive materials is still quite large. So at this point, you know, and as I mentioned, bringing the process efficiency is what's going to drive the cost down. And when you become closer to the incumbent material cost, I'm not saying it has to be cheaper or the same. I might say closer. Then you know we can make a decision if that premium is worth the marketing or the aesthetic advantage of it.
Okay, so he nods. Yep, answered. That question is answered. Anything else you want to know? Any other? Not at the moment, as it seems. I mean, my two questions now, after all this highly technical input, seem quite trivia. But what I'd like to know is, since we have a sample bar here where people can really touch and feel the different sort of textures and the different compositions, did you test it with customers? How do they react? I mean, you mentioned the engineering process, you mentioned the design process. What about the customer experience? Do you have any data on that?
Yeah, certainly. And I get my data from our marketing team. Certainly there is a customer value, right? There is a customer perception of value. You know, as having a black part that could be plastic, it could be metal, it could be something else. Now they know, hey, they're getting a premium aesthetic material. And actually the market's changing a little bit. Even in the corporate, you know, side of it, people have choices often. Bring your own device, where you're able to purchase your own device and bring it to work, or they offer our product along with our competitors' products, IT department, and you can pick. So it's about recognizing that even in the corporate side of the PC market, that people have choice. And so bringing something that looks premium and has the best feel and experience, as you mentioned, or better battery life, is attractive.
Okay, so customer centricity is very important when you go into this realm. Taking the other side, a customer could mean that also Covestro is customer centric when it looks at you and the collaboration. Mm-hmm. So how do you collaborate in order to come up with these ideas or these solutions, because they're rather solutions on a very practical basis?
Well, and I think it's leveraging learnings from other industries, really, and that's the value of working with suppliers like Covestro or other suppliers, is learning what are they doing in other industries, and how can we apply that to ours, right? It's not about inventing something new just in our space. It's about learning, and I'll even say this, stealing from other places, right? Automotive industry and our industry have a lot of similarities, from the need for automation, the need for high-speed production, the need for cost, certain cost targets. So it's how do you borrow and trade off? And the advantage of our market is, although we're not exactly so quick and fast as I think everyone would like us to be, we're much faster than automotive to get something to market. And I think that also gives suppliers an opportunity to learn more about their product, how to customize and create what they're doing. And then by the time that other industries are there to adopt it, they have a lot more experience with their own materials.
Okay, so it's communication and collaboration is all about learning, you say?
It is. And it's about learning together with your suppliers, for
exactly.
sure.
And Well, it was definitely a win-win-win situation to have you here. Thank you very much. I learned a lot, definitely. I think they all learned a lot as well. At least I hope so. And if you still have the desire to learn, we have one more talk coming up today at 3 o'clock. But for now, I say thank you very much to Nick Abbatiello from Dell.